Hello children, welcome to AIMS India's online classes. In today's video, from physics subject, motion topic we are going to continue. So here children, angle of projection for maximum range of the projectile. So you can understand this concept if you watch the previous videos children. So before this video, please watch the previous videos so that the concept continuation you can understand. So in this video, we are going to find the angle of projection for maximum range of the projectile. So what is the range children? Range means, so oblique projectile means projectile thrown upwards with an angle other than 90 degrees, with an angle theta which is not equal to 90 degrees. It is called as a projectile and its path is called as trajectory. The horizontal distance means the point of projection O2, it went up to maximum height A. From there again it came back to the ground B. Means from the point of projection to the point of again touching the ground, this OB. This OB distance is called range. Range of the projectile means horizontal distance travelled by the projectile. Now here the question is, if we throw with what angle, this horizontal range will be maximum. This horizontal range will be maximum. So this horizontal range, if we throw with what angle, then this will be maximum. That we have to find. So according to previous video children, the formula for range of oblique projectile, it is given by r equal to u square sine 2 theta by z. So the range r to be maximum, if this sine 2 theta value equals to 1. If this is 1, then that value will be maximum, because this sine theta value lies between 0 and 1. Means if this is 1, so this r value will be maximum. So this sine 2 theta equal to 1 means this 1 can be written as sine 90 degrees. Sine 2 theta equals to this 1, we are writing it as sine 90 degrees. So sine 2 theta, sine 90 degrees. So we can equate them like 2 theta equal to 90 degrees, or 2 theta 90 degrees, or 90 degrees can also be called as pi by 2, because where pi stands for, pi radians stands for 180 degrees. So 90 degrees can also be written as pi by 2. So 2 theta equal to 90 degrees or pi by 2, or theta equals to, this 2 will come down, 90 by 2 which is equal to 45 degrees, or 2 into 2, 4, pi by 4. So this theta equal to 45 degrees or 5 by 4 means the range will be maximum when sine 2 theta equal to 1. This will be equal to 1 when the angle is 45 degrees or pi by 4 radians. Means the range will be maximum for an angle of projection of 45 degrees or pi by 4 or pi by 4. What is that maximum range? What is that maximum range? This sine 2 theta will become 1, means u square into 1 by g, which is equal to u square by g is the maximum range. This we can observe for a body thrown with an angle of projection 45 degrees. Next, so the relation between range and maximum height. Relation between range and maximum height. So already we have derived the formula of children. This is the formula of range. R equal to u square sine 2 theta by z. You have to by heart the formula of children, so that whenever like this situations comes, you can apply the formulas. And this is the formula for maximum height reached by the body in the case of oblique projectile. This horizontal distance is r, this maximum height is h. Now we are going to find the relation between h and r. We know the formula of r, children, and we know the formula of h. Let's divide them. H by r. If we divide h and r, h value divided by r value, h value divided by r value. In the denominator, again we have fraction, so we can write it as u square sine square theta by 2z. Numerator into division, we are writing it as multiplication. Then we have to take the reciprocal of denominator. G by u square sine 2 theta. Like this we can take, or u square sine square theta into z. 2z into u square sine 2 theta can be written as 2 sine theta cos theta. This sine 2 theta can be written as 2 sine theta cos theta. So in sine square theta, 1 sine theta gets cancelled. 1 sine theta gets cancelled. So we will be having, so u square cancel. 1 sine square theta, 1 sine theta cancel. In the numerator, we will be having sine theta. Z cancel by 2 into 2, 4. 4. Sine theta cancel. We will be having cos theta. Sine theta by cos theta equal to tan theta. According to trigonometry, it is equal to tan theta. So, tan theta by 4. R can be written as 1 by 4 tan theta. 1 by 4 tan theta. Or this 4 comes this side. Actually, we have h by r. H by r equal to tan theta by 4. Or tan theta equal to this 4 comes this side. Tan theta equal to 4h by r we can write. So this is the relation between range and maximum height. The range and maximum height are related by the formula tan theta equal to 4h by r. In this, children, tan theta equal to 4h by r. So in this equation, h will be equal to r if the tan theta value equals to 4. 4 equal to 4h by r. 4 gets cancelled. R will come this side. R equal to h. So this h equal to r, or range of projectile, maximum height will be equal to one another if tan theta equal to 4. If tan theta equal to 4 will get cancelled, h equal to r. Tan theta equals to 4. Or this tan will come this side. It will become tan inverse. We can write in another way also. Theta equal to tan inverse 4. Tan inverse 4. Tan inverse 4 value is approximately 70 to 76 degrees. So when we throw with an angle of approximately 76 degrees, so then maximum height h equal to r. H value will be equal to r. This length will be equal if we throw with 76 degrees angle. So how we have got 76 degrees? Tan inverse 4, how it is equal to 76 degrees? No need to learn now, children. So you can remember the value while dealing with the trigonometry chapter in maths part. you can understand that. Okay, for at this moment only you have to remember this value, tan inverse 4 equal to 76 degrees. So if we throw with an angle of 76 degrees, range of projectile, maximum height will be equal to one another, or h equal to r. If tan theta equal to 4, then h equal to r. Next one. Same range at different angles of projection means the angles of projections are different. This is one angle, this is another angle, this is another angle. Though the angles of projections are different, but the range is same, like this. For this first projectile, for this second projectile, for this third projectile. If we compare the first projectile and third projectile, horizontal distance traveled by them is same, means range is same, but angle of projection of 1 is different, of 3 is different. Means we can get same range but for different angles of projections. Means suppose we know the formula of r is u square sine 2 theta by z. This is the formula for range. In this formula for range, if we replace the theta, by 90 minus theta, in the place of theta, if we replace 90 minus theta, what happens? Sine 2 into 90 minus theta, 2 into 90, 180, 2 into theta, 2 theta, 180 minus 2 theta. But in trigonometry, 180 minus sine 180 minus 2 theta equal to sine 2 theta. This value also you have to remember, children, equals to sine 2 theta. So u square sine 2 theta by z, which is equal to r. Means when we have theta value, r is same. When we have 90 minus theta value, r is same. Means for 30 degrees of projection, we will get one r value. 90 minus 30. For 60 degrees of projection also, we will get same value of r. Same value of r. Means a projectile will have same range for angle of projections of q and 90 minus q, or theta and 90 minus theta. For these two angles, the projectile will be having the same range. Same range. Only range is same, children. Maximum height will be different. Time of flight will be different. Only ranges are same for angle of projection theta and for angle of projection 90 minus theta. Remaining all other values are different. Here, children. So here, see, for theta and 90 minus theta, for these two, either theta or 90 minus theta or 90 minus theta or theta, for these two, the range will be same. The range will be same. Now we are going to find relation between time of flights in this T1, T2, T3. 3 different times of flights are there for these 3 projectiles, and height of a point means height of any point. Height of any point in the case of projectiles having the same range. Here, children, suppose if the angle of projection is theta, then time of flight for this projectile is tu sin theta by z. But For angle of projection 90 minus theta, time of flight, let it be T2, it will be Tu. In the place of theta, we have to write 90 minus theta. Sin 90 minus theta equals to cos theta. So when the angle of projection is theta, time of flight is Tu sin theta by z. When the angle of projection is 90 minus theta, time of flight is Tu cos theta by z. Tu cos theta by z. So if you multiply T1 and T2, T1 and T2, T1 and T2, we will get Tu sin theta by z, Tu cos theta by z, or T1 T2 equal to U into U. 2 into 2. Two into 2, 4 will come actually. Okay, let's keep 1, 2 here. Sorry, Charan, it is sin 2 theta. So 1, 2 we will kept side, and remaining part 1, 2 we will kept side. Here U into U, U square, we have sin theta into cos theta. This 2 sin theta cos theta will become sin 2 theta. This 2 sin theta cos theta will become sin 2 theta. We have 1, 2 here. We have U square. Remaining part will become sin 2 theta by this we can write as z into z. But this value which is in the brackets, U square sin 2 theta by z, this is equal to R. This is the formula for range. So 2R by z. We will get T1, T2 product of times of flights equal to 2R by z. So that is the relation between times of flights and range for same range. For different angles of projection, same range, the relation between T1 and T2 is 2R by z. If we divide T1 and T2, Tu by z gets cancelled, sin theta by cos theta will remain, which is equal to tan theta. Okay, children, that is the relation. When the range is same, when the ranges are same for two projectiles, the relation between their times of flights and range is T1, T2 equal to TR by Z. The relation between times of flights is T1 by T2 equal to tan theta. T1 by T2 equal to tan theta. Next one. Suppose, so this is a projectile. It has reached point P. From the ground in time T1, and from there to the ground in the time T2. Means if T1 is the time taken by projectile to reach point P at height h, which is at height h, that is not the maximum height, children. That is not the maximum height. This small h is given height. At height h, T2 is the time taken from point P to ground level. T2 is the time. Then, what is the relation between them? So here, T1 plus T2 equal to this T1 time, this T2 time equal to total time of flight. T1 plus T2, capital T equal to total time of flight, which is equal to Tu sin theta by Z. Or this Z will come this side, G into T1 plus T2, 2 will come down by 2. So U sin theta equal to G into T1 plus T2 by 2 we can write. Now, height of point P, if you want to find height of point P, it is in vertical direction. In vertical direction, this will be this will be affected by acceleration due to gravity created by gravitational force. So we can consider vertical motion in this case. Vertical motion in this case. So at point P, vertical velocity u sin theta, vertical velocity u sin theta, and height already they have given h, and time for going up to point P, they have given t1. So according to equations of motion, we know that s equal to ut plus half at square. According to that, s means height, small h, u means velocity, vertical component, u sin theta, t means time, t1, half, body is going up, g is acting downwards, so g is negative. In the place of half a, we can take minus g. In the place of t, we can take t1 square. Again, that equal to. So here we have got u sin theta value, g into t1 plus t2 by 2. So in the place of sin theta, we can keep z into t1 plus t2 by 2. Instead of u sin theta, we are keeping this value into t1 minus half gt square, half g t1 square, If you multiply, what happens? G t1 by 2, G t1 by 2 plus, sorry, this also is there, G into t1 into this t1, G t1 square by 2 plus G t2 into t1 by 2 plus G t1 t2 by 2 minus this half G t1 square means we can write G t1 square by 2. G t1 square by 2, G t1 square by 2 cancel, G t1 t2 by 2 or half G t1 t2. This is the relation between any height at any point, at any point, height reached by a body and time taken to reach that point, time taken to reach ground from that point, the relation between h t1 t2 given by this formula, h equal to half g t1 t2 given by this formula. One minute here. Next. So children, what we have learned today, children? So angle of projection for maximum range of projectile, which is 45 degrees, that we have learned. And the relation between range and maximum height, tan theta equal to 4h by r. When tan theta equal to 4, this h equal to r, that we have learned. Or when the angle of projection is tan inverse 4 or 76 degrees, h equal to r, that we have learned. For different angles of projections, a projectile can have same range, which is for theta and 90 minus theta. For two different angles of projections, range will be same. And the relation between times of flights, when the range is same, for theta angle of projection, 90 minus theta angle of projection. If this time of flight is T1, if this time of flight is T2, the relation between T1 and T2 is 2R by Z. 2R by Z, or T1 by T2 equal to tan theta. This is the relation. Or at any point, if the height is h, if the time taken to reach from ground to that point is T1, that point to ground is T2, then the relation between them is given by h equal to half z T1 T2. Okay, children. So remaining part we can learn in our next video, children. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.